Good morning. Today we are going to discuss the concept of threads. In one of our previous classes, we discussed what we mean by a process. A process is a program in execution, and using fork, we can create a new process. That means process is having a data area, stack area, and code area. Okay, but if you are creating a thread, that means thread is a lightweight process. Lightweight process in the sense, suppose that you have a process here. This is a process, and if you are forking, what will happen? The exact replica of this is created. That means, suppose that here you have code area, data area, and stack area. Everything is replicated. That means this is an independent process. That means everything is replicated, and here these are all replicated. That means process means a using fork. If you are creating a new process, in that case a new process with all the properties of a process. That means these two have no connection. That means this is an exact replica of this. But if you are creating a thread, what will happen? Suppose that here you have a process, and now at this point, this is in between. Suppose that you are creating a thread here. You are creating a thread here. What will happen? For a thread, only data area is different. That means this process is having code area, data area, and stack area. Code, data, and stack. That means when you are creating a new thread is created, what will happen? The data only differs. Code is same and stack is also same. That means here data is different. For example, in the browsing window you can have different tabs. That means if you are using the Chrome browser or Mozilla browser or whatever it is, here suppose that you are opening a new tab, the program is same. Suppose that you are browsing say www.google.com in one window, and in some other window you are going to YouTube, and in some other window you are going to KTU, then that means the data is different for all these threads. That means same code is executed, same code, but there are differences. That means at this point in time, you should note that code area is same. That means same code, no difference for code, but data area is different. That means when a new thread is created, a separate execution path is created. Code is same. That means here when this new thread is created and this is the code area, suppose that here this is the code, and suppose that your program counter is residing here, program counter is here, then for this new thread there may be some other execution path, and that means some other program counter will be simulated. Some other program counter is simulated, and suppose that some other thread is also there, then separate program counter is exists for that also. That means when you are executing that will be loaded. That means between threads you can switch. That is called context switching, and all those things. At this point in time, there is no need to study all those things. Anyway, should note that a thread is a different path of execution only is created with a different data. Entirely different process is not created. That means when you are creating a thread, that means here if you are creating a new thread using pthread create, that means in C you have a function like pthread create. This is for creating a new thread. At that point, what will happen? A separate thread is created, and the thread ID is returned. Thread ID returned by this is TID, and this is the set of, these are the set of attributes for that thread. What are the properties of that thread? That means initially, if you can set the properties of a particular thread, that means you are going to create a thread, and what are the general properties of that thread that can be set using p thread init attribute. That means you are going to set those properties. That means if you are creating a thread, what are the properties, or what should be the properties? That properties you have to already assign or set. That means that using pthread init attribute means you are going to set those attributes, like what should be the stack size, what should be the scheduling policy you are going to use, etc., etc. That means scheduling policy, say FIFO, LRU, etc. are there. That means those things you have to decide initially, and once you have a set of policies, that means the properties of attributes, or the attributes are set. Now we can create a thread using pthread create, and here you are having, this is the TID, that means the ID returned by, TID means ID returned by what? This is the descriptor, thread descriptor. This is pointing to the thread, and these are the attributes. That means this is pointed. That means the set of attributes, and this is the function. Means you have to switch to some other function. Switch to some other function, and in that function only we are giving what is to be executed in that thread. That is, it is just like a function code, and there are difference between function calls and this one. That means anyway, this is the function. This function is going to be executed as a thread, and these are the set of arguments that has to be passed to that function. Okay, that means this is for creating a thread, and this is the, once it is created, this is returned by the TID is returned, and this is the attribute. These are the attributes you have to pass, or these are the attributes already set, and this is the function which is, that means control is transferred to this function, and that function will be executed, and these are the set of arguments. And one thing you should remember, when you are creating a function like this, the method signature should be like this: void star function void star. That means that function, the method signature for that function should be like this, and you have to override that. That is given in your example, in your demonstration. I think it is example number 3. In that, that's given, and this is for creating a thread, and separate execution path is there. This is the separate execution path, and once it is completed, and once you have a thread, then here you are going to have a pthread join command. That means the main program is waiting for the thread to be completed. That means once you have, this is the main program, this is the main program, and execution, here a thread is created, and this is the thread, and this is coming back. Here you have a join command. Join command means, that means after creating a thread, it is executing, and when you have a join command or pthread join command, that means it is waiting for this thread to be completed. It is waiting for this thread to be completed, and once this thread has completed execution, and it is giving the information that it has completed, then only this main program can proceed. Okay, then only this main program can proceed. So that's all about thread. And what is the difference between thread and a process? Thread is a lightweight process in the sense separate data area is created. The code area is shared as well as stack area. Okay.